Okay, so let's go back and review before we even start doing anything else. Last week we discovered 4 different kinds of slopes. Is that correct? We have a positive slope. Can you describe what you will experience as far as having a positive slope goes? What does it mean to have a positive slope? Well, I know it's a positive number, but graphically, what does it look like to you when it's a positive slope? Yes?
The line is going up.
Yes, and remember that we learned to read from left to right. So when you read your graph, it's also from left to right. So that means when we experience a positive slope, the line typically goes up like that, right? That's a positive slope. And a negative slope simply means the line will go down. So at this point, the lines will go down. That means you have a negative slope. What else do we have here as far as slope goes? Horizontal line. Okay, so we have another case where the line is just basically flat. What does it mean to have a flat line? It's not going up, it's not going down, it's just flat like that. What kind of slope is that? Zero. Okay, so we have zero slope when the line is flat, and typically you will have this case when you have a fraction at a 0 on top with some number on the bottom. Is that true? Okay, so when you solve for your slope and you see this, I'm like, yeah, it's 0 automatically. And what is the last kind of slope that we learned last week? Vertical line. So we have a vertical line looking like this. And when we have a vertical line, it resembles you falling off a cliff kind of deal, you know, where you're going to be senseless after that. So undefined slope, this is what we're talking about, right? So whenever you experience a vertical line, and I'm asking you, what is the slope of that? Just say, can't determine, sorry, undefined. Okay, so the last kind is called the undefined slope because there's no value associated with it. So 4 different kinds of slopes. Now what I want to focus on today is you with the ability to just read out the points and be able to tell me whether it's positive, negative, 0, or undefined without having to solve. Can you actually do that? Well, let's take a look. Imagine I have these 2 points. Look at the 2 points, please. Analyze it for a little bit and tell me. If I asked you to graph these 2, what kind of slope would you have? Positive, negative, 0, or undefined? Think for a moment.
Negative.
Okay, and your reason, please. Why do you think this is a negative slope?
X axis.
Yes, go ahead, Anne.
Because then you go to the left 2 and then go up 5. And then for the second one, you go to the left 5 and then you go up 6.
So you kind of graphed it in your mind, basically, right? But you also notice that we are on a timeline, right? Is that true? Your x-axis is like a measurement of time. Think about this for a moment. I'm just going to lay it out for you. Think about this. If you look at your x component of your point, which point would be on here first? The negative 5, going from left to right, right? So if this is your 0, negative 5 would be right here. Is that true? And then comes negative 2, which is right here. Is that right? Remember, we do it from left to right all the time. Just keep that concept in your head. Reading from left to right all the time. So if you read your x, it's going to be from left to right. So negative 2, then negative 5, then negative 2. But look at the negative 5. At negative 5, the y is at where? 6. And then when it reached negative 2, what's happening to your y? Is it increasing or decreasing? Decreasing. Decreasing. Because of that, just by having that, you notice your line has to go down. Therefore, it's a negative slope, like you said. Very good. And so, I expect to have a negative slope. How do we find the slope again? Anyone remember how to find the slope?
Reservoir.
You line it up.
Yeah, you line it up. Basically, put it into a column, subtraction problem. So look, I line it any way you want. Negative 2, 5. Here's the next one. Negative 5, 6, right? I line it up. I split it apart, and here it comes. I'm going to put in the minus myself. This is a part that people always make a mistake on. I don't know why, but I highly suggest that if you have multiple negative like this, that you write the problem out horizontally. So I write it like this. Negative 2 minus negative 5. Do you see it? For some reason, when you write it, you don't write everything in, and so you end up with the wrong answer. So I'd rather have it out like this, and I realize that, hey, what do I do with these 2 signs? Combine to a positive, so my answer should be what?
3.
A 3, right here. Next one. 5 minus 6. That should be simple enough. Negative 1. Now here's your next question. Which one goes on top? Which one goes on the bottom?
Negative 1.
Y, negative 1.
Negative 1.
Very good. That's your structure, isn't it? Here's your y, and here's your x. So your foundation x is in the bottom, so I got myself a negative 1/3 as my slope. Any question on that one? We're good, right? So we analyze the points, we realize it's a negative, we answer it, and we got a negative back, so we know we got something right. Okay, so anticipate before you actually solve. Don't, solve and then realize that you made a mistake. Okay, what about this one right here? See if you can actually analyze this one. Before you solve, take a look at it and tell me what's going on with these 2 points. Put them on a timeline, plot them, visually plot them if you can, and what do you notice?
Horizontal.
Interesting. Nothing's changing on the y, huh? I mean, you start at time -3, it goes up to 5. And then you end at 2, and it's still at 5. So nothing has changed over that period of time. So instead of having to solve this, you realize that if it's a horizontal line, what kind of slope will we have? No change. Not up, not down. Flat out, it's 0. I don't need to spend time solving for it. So, 0 slope. Done. Horizontal line. Right? And if you have to set it up and solve, you will find yourself getting a 0 back. So here's another variation to the problem, so you can actually recognize. Let's say I have this. What happened this time? What did you notice?
Decreasing. Negative.
Okay, so as far as the time goes, does the time move anywhere? It stays the same, huh? Stay in the same spot, and then it stays in the same spot, and what does it do with that same spot?
The vertical line.
It goes up and down.
Undefined.
So because of that, you know that you experience this line, right? And we just learned that when we have a vertical line, it's undefined. And typically, why is it undefined? Let me just set it up and show you why it's undefined as well. But notice when I line these up. Here's my vertical. Subtract, subtract. -7 minus -7. If I write it out, it looks like this. I got myself a 0, right? And over here, 2 minus 3 is -1. And so here's y, here's x. So structure on top of foundation. I got a 0 underneath, and that should set up your alarm inside your head. Can't have 0 underneath. It's undefined. Never. Okay? 0 underneath is like having no foundation. You know what I'm saying? So your structure is unstable, it will collapse. Think about that. You need to have some kind of numbers there to support this whole thing up, and 0 is not sufficient enough, and so therefore it's undefined. Any questions so far on the different kind of slope and what you expect to have when you see certain things? Yes?
What if there's a 0 on top?
We talked about that, didn't we? What if there's a 0 on top? Which is the case that we just did earlier. Okay, you see that? What kind of line is that? Yeah, I know they're all straight. That's the thing. Avoid saying it's straight anymore because a line is straight. What kind of line is it though? If you have to plot it, what do you expect to see? Horizontal. Thank you. Right there, horizontal, right? And if you solve the graph, solve for the slope, it's going to look like this. Subtract, subtract. This becomes 2, and this becomes 0. So y on top of x is 0 over 2, which is 0. That's for horizontal slope. Okay, so this one's fine. There's structures holding up. There's a foundation holding up. That's fine, but 0 divided by any value other than itself is 0. Okay. Any questions on that one? We're good. Okay. Now, so far I just gave you 2 points. Easy enough. Easy to graph. What if now I just turn things around a little bit and say, wait, guys, I only have 1 point to give you. How's that going to change the problem? Okay. So let's say this. Let's just say that I give you this point right here. Can you give me the location of that point?
Negative
Negative 4 to negative 2.
Negative 4, negative 2. Okay. I'll give you another one, I'm sorry, but I need to make sure you understand this. But let's say I give you another point right here.
1, 2.
1, 2. Okay. Positive, negative, 0, or undefined slope? Just by looking.
Positive.
Positive. Can you quickly find a slope for me? How do I set this up again?
Subtraction.
Subtraction, good. 1, 2, negative 4, negative 2. Notice I don't even care which point I pick. I just line them up right away. And then I subtract. So subtract, subtract. Negative 4 minus negative, 1 minus negative 4. 5. 2 minus negative 2. 4. And this is y, this is x, so therefore it's going to be 4 over 5. Now this is where I'm going to introduce a new term for you. Of course, you have heard it before, but y is associating to up and down, and x is associating with left to right, right? So instead of saying y over x, we call it rise over run. Okay, I'm just making sure I mention it again. Now, but let me connect these 2 points for a minute. Let's right now connect. I know it's not exactly straight, but to make it straight, oh, come on. I have to make it straight. Recognize shape. Haha. It is now, should be, no it's not? Oh, come on. Okay, let me use this one. Oh my god. Wrong point. 1, 2, right there. Yeah, there you go. Okay, you see the 2 points crossing? Okay. Alright, so we have ourselves a line crossing through 2 points. Let's take a look at the slope for a minute. 4 over 5. And we know 4 is associating with y and 5 is the x, right? Rise over run. Tell me a little bit on what you think about the rise. If it's positive 4, are you going to rise up or are you going to go down? Okay, so positive in this case, so you know it's going to be going upward. Okay, fine. What about the run? Run is the horizontal movement or your foundation. If it's positive, do you go left or do you go right?
Right.
Positive. Right. Okay, so we have established ourselves the basic direction of your slope, right? Rise over run. Watch what happens as I start on any point. Let's say I start with this previous point that I got right here. Right there. Using my slope, it says rise over run, so rise up 4, so I go 1, 2, 3, 4, and then from there, where do I go?
5 to the right.
5 to the right. 1, 2, 3, 4, 5. Guess what? If I use the slope, I will end up on another point on the same exact line. Okay? Why am I showing you that? Well, just wait for a minute. But you use the same slope again. 1, 2, 3, 4, 5 up. 4 up, right? 4 up. And 5 over. 1, 2, 3, 4, 5. Guess what? I will also land on another point. Not anywhere on the graph, but on where?
Line.
On the same line. So if I continue this path, what do you think will happen? Will I ever land outside of the line?
No.
No. So what it means is, do I need 2 points to make a line anymore? Not exactly. I can technically just give you 1 point and a slope, and that's all you need to get to another point on the line. So even if this line is not here anymore, but I give you what we call an anchor point. This is where it's kind of cement and stone, basically. It stays there, and it tells you where to start it all. If I give you an anchor point, all you need to do is use the slope to get to the second point. So watch. 4 or 5, you go up 4, and you go 5 right. Right there. 4 up, 5 right. Right? Is that true? Is there, okay, so we have this going to the right-hand side. Is there any way for us to go back to the left? Is there another way to write 4 over 5? Think about that for a moment. Is there another way to write 4 over 5? Thank you. You actually write negative 4 over negative 5. Is it negative 4 over negative 5 the same thing as 4 over 5?
Yeah.
Okay, but using that, you end up with 4 down and 5 left, right? So look, 4 down, 5 left, right here. And guess what? If I actually take this line again and match it all up, I should have my line crossing go over 4 points. See it? So what I mean is, this is how you actually obtain a line by utilizing just one point, and in this case, what you need as an extra is what? The slope. So you need a point and a slope to make a line as well, okay? Without having to use both points. Okay, any questions so far on this? On how to make a line using a point and a slope. Okay, let me ask you this then. What if, let's restrict this line for a minute. So here's my point. Let's say I give you -2, 3, and I give you a slope of 0. What did I just give you?
An anchored measurement.
Okay, I give you an anchor, which is at -2 and 3, right here, right? So I give you an anchor point. What do you expect your line to be this time around?
Horizontal.
Yeah, because the slope is 0, so all you have to do is basically draw yourself a line like that, and then hey, I got my slope and my line. Done. That's easy, right? What if I give you a same anchor point again, but this time the slope is -1/3? What does it mean? How do I get to my second point using the same anchor point?
1 down, 3.
Okay, so you automatically associate with rise over run, right? In this case, you match it up saying, wait, rise -1 means I go up or I go down? I go down, so I automatically put an arrow to indicate that I have to go down first, and then the run is right and left.
Right.
Right. So then I just go here and say, okay, so I go down 1 and run right 3, down 1, run right 3, 1, 3, 1, 3, and notice I will have a line that way. See that? Okay. Another version, please. What if I have this? Or no slope? Okay, what do I mean? How do I graph that one now? What do you expect to see though? Automatically. A vertical line. There it is. So I just quickly graph it without having to put much thought into it because I expect a vertical line to begin with. Okay, here's the last one. What if my slope is a +3? How do I graph that? Interesting. Notice what Nicholas just said. He didn't say 3. He said 3/1. Why did he convert a 3 into a fraction? Why?
Because you need to have a run.
Yeah, you need to have a run as well. So it's rise over run. That's a fraction. So if I just give you a number, a whole number, make sure that you convert that into a fraction because we associate our slope with rise over run. And so a fraction in this case, it's going to go up 3 and 1 right. Is that right? Okay, so let's graph. Up 3, 1 right, up 3, 1 right. And of course, what if I don't have enough room on my right-hand side? Where can I go now?
Down.
Down. So I just have to take the opposite of this, which makes it -3/1. As long as I don't change the actual value when I evaluate it, I'm fine. So in this case, I go down 3, left 1, down 3, left 1, and if I connect every point, I will have myself a line. Questions at all? And by the way, I mean I'm just throwing it in there without formally introducing it, but the letter M right here, because I hate writing the word slope every single time. So the next time when you see the letter M, it means slope. Okay? So I'm using the shorthand for slope. I don't want to have to write slope is. I just write M is. So M is for slope. Any question on how to plot a point? I mean, graph a line using a point and a slope. They just pick letter M. Okay. Any question on it? So your homework's pretty simple. It's the same thing, really. I just want to make sure you know how to graph a line this time using a point and a slope. Let me pass this out.